everyone, welcome back. And in today's session, I want to demonstrate the concept of inline functions in C++. So let me start. Hash include IO stream, and then using namespace standard, and then I want to define a function here. Suppose let me take a very simple function, say square, finding the square of two integer values. So the return type is int, and also the parameters, only one parameter. Oh god, only one parameter, int, say x, right? And then this function is basically performing a simple task of finding the square of an integer value, right? So return statement x into x. That's it. That's the task of this function. It's a very simple and less complex function, a single line code, right? So such functions can be inlined. So if I prefix the keyword inline to this function definition, then as a programmer, I'm suggesting the compiler to consider this function for inlining, right? Because because just by using the keyword inline, the compiler won't inline the function. The compiler decides. We are just suggesting using the keyword inline to the compiler to decide. Okay, the compiler then decides whether to inline this function or not based on the complexity of the code, based on the complexity of the function code. If the function code is around 3 pages, then the compiler will refuse. And if the function code has some recursive task, then the compiler will definitely refuse. So because the complexity is severe, so the compiler inlines the function only if the function code is less complex and a small piece of code. In such cases, to avoid the overhead of a traditional function call, then the compiler will decide to inline such less complex functions. Here I'm prefixing the keyword inline, but in modern compilers, what happens is the compiler automatically decides to inline certain less complex functions without the keyword inline. So I'm just demonstrating here using the keyboard inline. So next, within the main function, I will take two integer values, say for example 3, and then I want assign for b the value 5, right? I will use the cout statements to print the square of these two values. So I will comment this line. Okay, square of a is equal to, so now I will invoke the function square. This is the function call, and I'm passing the parameter a. So here, done. Next line, similarly for the value b, copy this. Okay, similarly for the value b, I want to find the square, and I'm passing the argument b, right? So here, let it be on the next line. Okay, so now So basically, the inline concept is at the place of the function call, the body, the function code is substituted. That's the you know mechanism here. uh, Whenever there is a function call, the inline function is replaces it. The inline function code, the body, the function body replaces the function call. So that is the primary mechanism of inline. And why is it done? As I already told you, the to avoid the function call overhead. Okay, usually what happens is whenever there is a function call, um, the suppose say here the at lines 16 and 17 there is a function call. So the parameter a has to be pushed onto the call stack, and the control has to jump from calling function to the called function, here from main function to the square function. So during that time the return address has to be pushed onto the stack. So once the called function is executed, the control has to jump uh, to the calling function again. So the return address from the call stack, from the stack, has to be popped out. So this is the overhead faced during the function calls statements. So to avoid this overhead, the keyword inline is being introduced and is used in the programs. So now um, let me run this code. So this is how we use the inline function keyword, and this is how we invoke, and this is how we make the function call. Okay. So there is other disadvantage of using inline, if I have to mention. So whenever there is a function call, the function code is replaces the function call, right? So it may uh, increase the length of the compiled code, you know the number of lines of the compiled code, but and henceforth it is applicable only for the less complex and fewer lines of coded functions. So as you can see, the square of a is 9 and square of b is 25, 3 and 5, right? Okay, I missed the spelling here. Okay. Okay, and once again run it. So guys, yeah, this is the obvious output. For 3 it is 9, for 5 it is 25. And suppose if you want to inline a member function inside a class, then I can demonstrate with an example. So let me remove this. Okay. Oh, I just took away the curly brace. Okay, now I just want to demonstrate inline function, inline member function basically inside a class. So let me define a class now. Okay, suppose say let me take the name of the class is rectangle, and opening and closing curly brace for the definition of the class. Under private access specifier, I would have two members. One is width, is this, okay, and the other one obviously is the height. Okay. Okay, now then under public access specifier, okay, under public access specifier, I would obviously have a constructor by the same name as that of the class, rectangle, and I will take two parameters, one for width, initializing width, uh, let it be w, and then int h. Okay, I would initialize width with w and height with h, right? So there is this one. Okay, so now after the constructor definition, I would define an inline member function which would find the area of the rectangle, right? Okay, a simple task. Inline keyword and return type obviously int, because the width and height are integer data types. So the name of the function, I would take it as area, and then the function body, the only a return statement which is finding the area. So width into height, right? So done. This is a member function. Okay, inline member function. So the first thing we do inside a main is declare an object for the class rectangle. Object name, I would say obj1, and I would pass two parameters for width 3 and for height, let me say 6. Done. Now I want to invoke the inline member function. So for that I would take a cout statement to print the area on the console. Area of rectangle is equal to, here I would invoke the inline function area. That's it. Okay, so inline keyword, once again here it serves the same purpose, just like whether it is used inside the class or outside a class, the inline keyword serves the same purpose. We are just suggesting the compiler to consider the function for inlining, right? So so one thing I have to mention, inline functions definitely improve or increase the execution time, in the sense the faster it fastens the execution time of the function code. So that is one advantage. So let me run. The obvious output would be 3 into 6, 18 of. Okay, so this is how we use the inline keyword inside a class. Okay, hope you guys have understood. Okay, thank you.